So first of all, I don't know. Is it recording? I hope so. Okay, I hope it's recording. Well, anyways, um, this is the sheet you were working with in class, and you guys were doing such a wonderful job. But I am going to do it anyway, just in case some of you guys want to check your answers. But what I saw today was wonderful. Um, and let's start this. No, let's not start this. Can we start this? Yes. Uh, All right, now my pen is ready. Okay, so let's get this done. So here we go. So we have two things here. We have this whole bracket here and this whole parentheses. These are two unknown values. All of that's going to boil out to one single number here and here. So we got to figure that out. Okay, so this whole thing here is just a fancy way of saying a particular number that we don't know yet. So remember, we should always take care of our unknowns first, right? So let's just do that. So here we got 6. Take care of the exponents. 4 and 4 is 16, divided by 2 to the third, which is 2 times 2 times 2, which is 8, plus 6, minus 5 to the second power is 5 times 5, 25, minus 20. And that's all I'm going to do here. You could have done a little bit more, but I'll do this. So again, the 6, and if those of you who might not remember, you can put a little dot just to let you know that this is going to be multiplying everybody in the parentheses here, right? So 16 divided by 8 is 2, and then plus 6 is 8. So that, like I said, all this is just a fancy way of saying 8, right? So minus, and this parentheses, 25 minus 20 is 5, and we need to raise it to the second power, which is 5 times 5, and that gives us 25. So now we're ready. We have two operations. We have a multiplication and a subtraction. We obviously know that we have to do the multiplication. So 48 minus 25, and we get 23. Okay. On the right, we have some variables here, which we have to switch to to the values that are given. So Amy, AMY. Yeah. So you get 2 times 6 times 4 minus 3, and the m is 6, and plus y, which is 4 to the third power. We can do the exponents, right? So that would be our first step. So I'm just going to follow order of operations here and leave everything alone and take care of this guy, which is 4 times 4 times 4. 4 and 4 is 16, times 4 is 64. So now we can do this. We have multiplications and additions, so let's take care of all our multiplication. 2 and 6. So I would do 6 and 4 first, which is easier for me, 24, and then double that, 48. Minus 3 and 6 is 18, and then 64. Again, place from left to right, ladies. 48 minus 18 is 30, plus 64 is 94. Hopefully I'm doing this right. And let's move on. Okay, so this one, 3 times. So again, I'm going to do it right under. So we get 3 times, and we're doing the sum. So the sum indicates addition, right? So I need to put the addition. I'm going to just space it out a little bit. I'm going to put addition here. And when you're adding, of course, you're adding two things, this and this guy, right? So what are we adding here? A number squared, a number that I don't know, to the second power, and what? 4. But for this one, I need to do something special. I need to protect this sum here, right? Because if I don't leave it with the parentheses and I leave it like this, and if I asked you to solve this, what would you do first? You would multiply 3 and n after you did the exponents, of course, but you would do 3 times n and then plus 4. But while there's a parentheses here, it forces you to do the addition first, right? So, and that's what we want. We want the sum. So we want to find the answer to this two numbers being added and then multiplied by 3. So therefore, we needed the parentheses. So this would have been incorrect. So evaluate the expression if the number here, the unknown value is 2. So let's just substitute 3. Instead of the n, I'm going to write 2 to the second power plus 4. And again, I'm going to continue. 2 to the second power is 4, plus 4 is 8. And then 3 times 8 is 24. So that would have been your final answer. Moving on. Um, yes, I understand there are different ways of doing it. I will just pick, I guess, what I believe to be the easiest. I might be wrong if you have a different choice. Whatever process you take, don't matter because we'll both get the same answer. So 9 over 16, divide it, right? So this is a decimal. To me, I would change that to a fraction. So if I look at the 2, it's in the tens place, so it's 10, and then 12 goes on top. So 12 over 10. We're going to divide, so take that, and take that. Is there anything we can simplify? Yes, there's actually quite a lot we can simplify. Um, let's do 10 and 12. So 9, so let's simplify before multiply. So let's divide this by 2. 10 divided by 2 is 5. 12 divided by 2 is 6. Can I simplify anything else? Yes, the 9 is 6. I can divide both numbers by 3. 6 divided by 3 is 2. 9 divided by 3 is 3. Is there anything I can simplify? 3 and 16, no. 3 and 2, no. 5 and 2, no. 5 and 16, no. So now I'm ready to multiply. 3 and 15, 3 and 5, sorry, it's 15. 6 and 2 is 32. So that's our final answer. Okay. Likewise here, I have to subtract first because it's in parentheses and then do the division. So let's take care of this and worry about the division later. I like, especially because I know I'm going to be doing some borrowing, to change this right away to an improper fraction. So I get 3 times 3 is 9, plus 1 is 10, 10 over 3. Minus 8 times 1 is 8, plus 7 is 15 over 8. I again divided by 0.6, and I need to find the LCM, which is going to be 24, right? The first multiple. You don't have to use 24. You could have used another bigger multiple, like, I don't know, what do they also share? 48 they share together, right? So it's 3 times 8, so here I'm going to get 80, right? It's times 8 over here, so times 8 on top. 8 times 3 was 24, so 8 times 3, and then times 3 here is 45. Now I can subtract these two. Right, so I get 24, 80 minus 45 is 35. And I can now divide that by 0.6 or change that to a fraction, which is 6 over 10. I will now change this to a multiplication problem. And I then will simplify if I can. 10 and 6 I can simplify. Divide this by 2 is 5. Divide this by 2 is 3. Is there anything else I can simplify? Ugh, no. So 35 times 5 is, I have no idea, 25, 175. 24 times 3 is 1272, it looks like. So yes, you can leave it like this, but if anybody bothers you, change it to a mixed number. So 72 goes into 175 2 times, because 72 plus 72 is 144, right? So I know it goes 2 times up to 144, and then to see how much left over, I'm going to subtract, and it's going to be 1. I have 31 left over 72. A rectangle. Okay, so here we have a rectangle. It's always nice if you draw it. The length is 5m plus 3. The width is 3m plus 8. So I know that this is also 3m plus 8, right? Because in the rectangle, opposite sides have the same measurements. And now this becomes a combining like terms, right? So you can, I will do it. It's going to be lazy, but I'll do it. So I'm going to write the expression plus 3m plus 8, because that's what it's telling me to do, 3m plus 8. And I'm going to circle all the like terms. It's 5m over here, plus 5m, plus 3m, and the plus 3m. So if I combine those terms, it's 5, 10, 13, 16m. And then I have a 3, plus a 3 is 6, plus an 8 is 14, plus an 8 is 22, plus 22. Okay. Oh, this one doesn't seem too hard. Order of operation tells me I have to do these two first, right? From left to right, if I have a choice between, division and multiplication. That's a 4. And then times 5 minus 17 That's a 20. And then you get 3. Over here, 72. Please don't add this 72 with this 2 because this 2, and again, those of you who forget, put a little dot there just for you to realize, know that, not to forget that you're multiplying that 2 with whatever this whole thing ends up being. So what do we have here? So let's do I'll leave that here. And then I'm going to do 2 to the third power, which is 2 times 2 times 2, which is 8. All right, so again, 72 plus 2 times, and let's see what we can do here. 54 divided by 6 is 9, and 9 minus 8 is 1. So that whole thing became 1. So now I have 2 operations, in addition and multiplication. I have to do multiplication. 72 plus 2 times 1 is 2, and finally 74. Let's move on. Okay, so this is just a simple addition problem, and again, let's change this. So, okay, so let me figure this out. So if I leave this 6 here and I change it to 35 plus 3, and I change this to 35, right? Because we have to find the common denominator. So 7 times 5 is 35. So if I multiply it by the top, I get 25, right? 5 times 7, and then times 7 on top, so I get 21. So now I'm ready to add, right? So you could have changed this to an improper fraction if you like to. I'll just do it this way for this problem. And the next one I see, I'll change everything to an improper fraction. So in this case, let me add the whole numbers. So you know what? So 6 and 3 is 9. 35 stays. And then on top, I get to add 25 plus 21. 25 plus 21, and that's 46. Now this is a problem because this is a mixed number, but a mixed number was an improper fraction. I gotta change this 46 over 35. So this 46 over 35 becomes what? 1. 35 goes into 46 one time. 11 left over 35. Now you will notice that my answer has a 9 and a 1 as whole numbers. I can't have 2 whole numbers, so I'm gonna add the 9 and the 1. So 9 plus 1 is 10, and I put that like this, and I combine. This one, I'm gonna add 3 and 3/5. I'm gonna change the 0.8 to a fraction, and that's going to be just 8 over 10. And what you also can do is change 8 over 10, simplify 8 over 10 to 4 over 5 if you wanted to. Ta-da! And now you can add, because they're the same denominator. So the 3 is a whole number. We're not adding it to another whole number over here, so I'm just going to leave it alone. The fractions I can add, 5 and 5, sorry, the denominators just stay. And 3 plus 4 is 7. And again, this is the same case that I had over here, where it was a mixed number, was an improper fraction. So let me just copy that over here. So we got to change this guy here. So 7/5, 5 goes into 7 one time. 2 left over and a 5, yeah? Now I have a 3 as a whole number and a 1 as a whole number. We can combine those two. That's going to give us 3 and 1, 4, 2/5. Okay? Again, you had a couple ways of doing this, a few ways of doing this, and this is just one of them. Change to an equivalent decimal. So we want to divide, so let's take this guy. 55 goes inside, right? So 12 goes into 55 4 times, which is 48. 4, 15, 7, add a dot, add a 0. Bring that 0 down. 12 goes into 70. 5 times, which is 60. 10, add a 0, keep going. 12 goes to 100 8 times, which is 96. 4 left over. Bring a 0 down. 12 goes into 40, I don't know, 3 times, which is 36. 4 left over. And 0 comes down, and now we can tell that this 3 is going to be repeating, right? because 36, and then 4 left over. Now the 0 comes down, and we can tell that the 3 is repeating. So the answer is 4.5833333 forever and ever, or we can write 4.583 bar notation on top of the 3. Okay. 8 divided by 15, 8 goes inside. 15 does not go into 8. 15 goes into 85 times, which is 75. 5 left over. Add a 0, bring it down. 15 goes into 53 times, which is 45. 5 left over. Okay, I think we have a repeating number already. 3 left over. 45, sorry. 5 left over. So again, that pattern is going to continue. So it's going to be 0.53333 forever and ever, or we can just rewrite it as 0.5. There's a bar notation on top of the 3. Okay. Why didn't they erase? No. So this one you had to substitute, right? So let's just make this a little bigger. So the first one, let's replace them with this 3 times 4 times 5 minus k squared. K is 4 to the second power plus m, which is 8. Okay, order of operation tells us we got to change the exponent first, so let's just leave this alone. You could have done it. It's not going to, I'm just doing this in order. 4 to the second power is 16 plus 8. Now I'm going to do the multiplication. 3 times 4 is 12. 12 times 5 is 60. So this whole thing is 60 minus 16 plus 8. Left to right, we do subtraction. That's 44 plus 8 equals no. 44 and 16 is, no, I'm right, 52. Here, let me substitute again. It's 5 times h, which is 5, plus 2 times m, which is 8. Oops. 8 to the second power, plus m again, which is 8. So we have to take care of the exponents. Actually, you have to, because if you multiply 2 times 8 right now, it is not correct. Okay, it's 2 times 8 squared. So let me just copy, and 8 squared is 64 plus 8. Now I can do my multiplications. 5 and 5 is 25, plus 2 times 64 is 128, and then plus 8. Add these two first, gives you 153, plus 8, 161. H squared plus, so it's h, which is 5 times 5 to the second power, plus 4 times m, which is 8. Again, don't multiply these two 5s together because it's 5 times this number squared, so it's 5 times 5 squared is 25, plus 4 times 8. Now let's take care of the multiplication. This is 125, plus 4 and 8 is 32. Now we can add, it's going to give us 157. HKM, 5, 4, 8 minus 4 times 8. Okay, so here 5 times 4 is 20, times 8 is 160, minus 32, and 160 minus 32 is 128. I could be wrong. A lot. No, it's not that bad. Sort of. Ugh. All right, so let's do the next. Well, these are not that bad. Okay. So again, we want to multiply. So before we multiply, we're going to change this to an improper. 4 times 2 is 8, plus 3 is 11 over 4. 3 times 3 is 9, plus 1 is 10 over 3. So this one's pretty simple. We can simplify this. 10 and 4. 4 divided by 2 is 2. 10 divided by 2 is 5, and then we can now multiply 55 over 3. And this is, 17, 18. 18 times 3 is 54. So 3 goes into 55 18 times. 1 over 3. 4/5 times 7 times 3 is 21 plus 5 is 26 over 7. Okay. Can we simplify anything? No, we can't. The bottom, 5 times 7 is 35. 4 times 26 is, I have no idea, 104. And 35 goes into 104. 72 times 70, so there's going to be 34 left over 35. Okay, these are nice and simple, so just remember that you have to change it to an improper and then multiply. Okay, so a lot of this is just you building fluency. Okay, so let's take care of this one. This is a division problem, so likewise, let's change this to an improper fraction before we do our division. 5 times 3 is 16, right, times and plus 16, 5 times 3 is 15 plus 1 is 16, sorry, over 5. Now I'm going to divide by 7/8, and 16 over 5, we gotta change that to multiplication and multiply by the reciprocal, right? Oh, can I simplify anything? No. 5 times 7, 35, that's 48, 128. 8 times 6 is 48, goes 4, yeah, 128. 35 goes into 108 3 times. All right, so you can always just divide, come over here and go like this. 35 goes into, not goes in 1, not in 12, but in 128, I'm going to say 3 times. If it's 3 times, 3 times 5 is 15, co 1. 3 times 3 is 9, plus 1 is 10, so 105. 23 left over, so that was right. So 35 goes into 128 3 times. You're going to have 23 left over 35. Again, change. 2 times 5 is 10. 11 over 2. Divided by 3 times 2 is 6. Plus 2 is 8. 8 over 3. So 11 over 2 times 3 over 8. Ugh, nothing to simplify. 11 times 3 is 33. 2 times 8 is 16. And 16 goes 32 times, because 16 plus 16 is 32. So it's 2 times, 1 left over 33. Isosceles triangles. So remember, we sort of somebody defined that for us. An isosceles triangle usually, not usually, but it looks like this, where two sides, this side and this side, okay, are congruent, they measure the same, and this third side is different. All right, so if we draw that, it says that it has, the base is this one, right? So this base is 4y plus 5, which means that the two sides that are equivalent is 5y plus 2, and because they're equivalent, obviously this side is also 5y plus 2. So we want to find the perimeter, so we're adding all 3 sides. So 5y plus 2 plus 5y plus 2 plus 4y plus 5. 5y like terms, this is a y, this is also like, so you have 3 like terms here, 5y, 5y, and 4y, that's 14y. Plus 2 plus 2 plus 5 is 9, right? 2 and 2 is 4, plus 5 is 9, so these are the other like terms, this, and that. Okay. Combine, speaking of like terms, here they are. So over here, let's see, we're going to combine like terms. So I would, is this 5m with the plus 12m? Put a triangle over here, and I'll put a triangle here. So I'm going to move things around this time. 5m, the 9m is going to come next to it, the plus 12, and then the minus stays in the back. So I can combine these two, 14m, and combine these two, 12 minus m is 3, so 14m plus 3. This one, oof, this and this are the same, minus w2, and this guy in the back is the same, so I should have used a different color, but so I went, these two are the same, and these two are the same, so there. So let's move them together. 3w squared minus w squared plus 5w to the third power minus 3w to the third power, and then plus 2w to the fourth power. So all my like terms are next to each other. So this is next to each other, the w3s are next to each other, and the w4 is by itself. So remember that there's a 1 here, right? So it's literally 3 minus 1, which is 2w squared. This one's 5 minus 3, which is 2w3. 5 minus 3 is 2. And the last one, I do absolutely nothing with it. What is next? Change the expression to algebraic. Okay, this one is easy. Yay! Sum. Find the sum. So I'm going to... Sum means addition of what? 3 times a number. So here's 3 times the number. So I'm adding 3 times the number with who? Is 8. Quotient means division. And what am I dividing? A number. That goes on top. And 5. 9 is 9. Less than means subtraction. Twice means 2 times a number. I don't know. Not done because of the less than. So I'm going to switch things around. I'm going to switch 2n goes to the front. And my 9 goes to the back. So this is the final answer. 4 is 4. More than means addition. Product means multiplication. So I'm going to multiply 2 things. What am I multiplying? A number that I don't know. And 6. Just to clean things up, I will write 4 plus, instead of writing n times 6, it's convention that we write the coefficient first and then the variable. So 6 times n. It won't change the answer, but we write the coefficient first and then the variable. Okay, so 4 plus 6n. If you left it this way, just FYI, on the test, it'd still be correct. But I still want to see it this way. Ugh, yuck. Yuck and yuck. Oh, 6 more problems. Okay. Ugh. Okay, these are not pretty problems. So, okay. Honestly, in this one, I would change everything to a decimal. Why? Because I know what the decimal of this is, and I know what the decimal of this is. These are very easy decimals. So 4/5 is 0.8 plus 0.6. Half as a decimal is 0.5 plus 0.95. So this problem, decimals are the way to go. So these two added, 0.8. So 0.8, line up your decimals. Gives you 4 goes 1, yeah, 1.4 minus 0.5 plus 0.95. So we can subtract 1.4 minus 0.5, right? There's going to be some borrowing here. That's a 0. 14 minus 5 is 9, so 0.9. So this is going to be 0.9 plus 0.95. And that's just going to give us 1.85. This one, I also would change it to decimals because these are decimals that I know. Anything that finishes in the denominator of 5, denominator of 4, denominator of tens are very easy to do. You just need to learn those, right? So 2.2, if you want to change it to a fraction, be my guest, that's okay. 2.2 minus 0.9 plus 1.25 is 0.4, so it's 1.4. Minus 0.7. Look how much easier it is to do this as a decimal. Okay, so it's 2.2 minus 0.9. 12 minus 9 is 3. So this becomes 1.3, which I'm going to add to 1.4 and then subtract 0.7. So 1.3 plus 1.4, again, let me do it here. 1.3 to 1.4 is 2.7, so this becomes 2.7 minus 0.7. So if I had $2.70 and I took away 70 cents, this one is pretty straightforward. So I would have 2. Okay, just an FYI here. Let me just write these. So 1 over 5, 2 over 5, 3 over 5, and 4 over 5. 1 over 5 is 0.2. 2 over 5 is 0.4, 3 over 5 is 0.6, 12 over 5, 0.8. Remember, so let me take 4/5, for example. It's 4 divided by 5, right? Can 5 go into 40? No. Add a decimal. Add a 0. Can 5 go into, sorry, can I go to 5 go into 4? No. Can 5 go into 40? Yes. 8 times, right? No left over. So 4/5, and I'm showing you how 4/5 is 0.8. So the fifths go like this, okay? I can also tell you that the fourth, 1/4, 2/4, 3/4, right? 1/4 is 0.25, right? 2/4 is 0.50 or 0.5, and 3/4 is 0.75, right? So those ones you should know. The tenths, 1/10, 2/10. I'm not going to write all of them down. 3/10, and so on and so on. So 1/10 would be 0.1. 2/10 would be 0.2. 3/10 would be 0.3, and etc. etc. Okay. But again, if you chose to do this as a fraction, that's completely okay too. What is this? Division. So we're going to divide 7 over 15. I'm going to change that. Remember, 5 is in the hundreds place, so it's over 100. 45. You should simplify 45 over 100, or we can simplify later. It's okay. So 7 over 15 times 100 over 45. Can we simplify anything? Now 145, yeah, because they're both divisible by 5. So 45 divided by 5 is 9. 100 divided by 5 is 20. Is there anything we can still simplify? Yeah, 15 and 20, they're still divisible by 5. 20 divided by 5 is 4. 15 divided by 5 is 3. Now we're ready to multiply. 7 times 4 on the numerator is 28. 3 times 9 at the bottom is 27. Or that can change to a mixed number. 27 goes 28 one time, and 1 over 27. Yeah. This one, same thing. 6 over 25. We're going to divide that by 85 over 100. You can simplify now or after you change it to multiplication problem. Times, let's use a reciprocal, 100 over 85. Let's simplify. Let's divide this by 25. 25 divided by 25 is 1. 100 divided by 25 is 4. Is there anything else we can simplify? 4 and 85? No. 4 and 1? No. 6 and 1? No. 6 and 85? No. So 6 times 4 on top is 24. 1 times 85 at the bottom is just simply 5. That's our final answer. 4 more problems. Yay! These are the work. They require a little bit more work. So let's do this. Let's change everything to impropers. 5 times 3 is 15. Plus 4, 19 over 5. Plus 2 times 1 is 2. 3 over 2. Divided by 1.2. Find the common denominator is 10. 5 times 2, and then times 2 on top, so it's 38. How did the 2 become in 10? Times 5, and then times 5 on top, we get 15. So 38 plus 15 is going to give us like 53 over 10. And we're going to divide that by 1.2. And then with 1.2, we can express as a fraction. Sorry, 1.2, which is going to be 10, and on top is 12. 53 over 10 times, we're going to use a reciprocal, which is 10 over 12. This one is nice, connect this 10 and this 10, right? We'll cross out because 10 divided by 10 is 1, 10 divided by 10 is 1, and you get 53 over 12. How many times can 12 go into 53? 4 times, 5 left over 12, because 12 times 4 is 48. Right, so it can go in 4 times. You're going to have 48, 53, 5 left over, because that's the difference, over 12. Not that bad of a problem. Here, same thing. Yeah, let's change this to an improper. So 3 times 2 is 6 plus 1. So you got 7 over 3 plus 11 over 12. Yeah? And divided by 2.3. LCM is 12, right? This is one that's already a 12, so no change is necessary, but the 3 became a 12 times 4. So the top is times 4. 7 times 4 is 28. In parentheses still, divided by 2.3. I can now add. 28 plus 11 is 39 over 12. And when I divide this, and again, let's change this to a fraction. So the 3 is in the 10th place, so I can put a 10, 23 on top. Changes to multiplication, so I get 39 over 12 times 10 over 23. Is there anything I can simplify? Oof, I can. I can divide 39 and 12 by 3. 12 divided by 3 is 4. 39 divided by 3 is 13. Is there anything I can simplify? 4 and 10, they can both be divided by 2. 4 divided by 2 is 2. 10 divided by 2 is 5. Now, truly, I don't have anything else. So 13 times 5 is 65. 2 times 23, 46. So I can leave it like that, or they ask you to change the mixed number. So 46 going to 65 one time. And it's going to be 19 left over 46. Last two questions, yay. So I need a bonus word, don't I? So I have to think of one. So here is your clue. Mozart effect. Effect. You can Google what that is later. Okay. But apparently playing Mozart to babies has a good positive effect on their brains. So that's your bonus word. Anyways, back to this. We're gonna add this. You can change them to a decimal. You can change it to a fraction. So I'm gonna do it two ways. Let me change this to a decimal. That's gonna stay. And this is going to be 3. And 9 over 10 is just 0.9. So 9 tenths, remember, is 0.9. So this 3 and 9 tenths is 3.9. And I can add these two. So it's 3.9, 0.88. I'm going to add this as a placeholder, this 0. And I'm going to add 8, 17, and I get 4.78. Let me do it on a fraction over here. So if you did it as a fraction, you would change 88. Last digit here is in the 100, so it's 88 over 100 plus 3 and 9 tenths, right? I have to change the 10 here to something over 100, so it's 88 over 100 plus 3 and 100, right? So it's times 10, so it's will be times 10, so it'll be 90. Now I can add. There is no whole number here, so no whole number plus 3 is just 3. On top we get 8, 178 over 100. So again, we have that problem here where this is a mixed number. It was an improper fraction. So let's change that. 100 goes into 178 one time. 78 left over 100. Now I have these two whole numbers, right? So I can join 3 and 1 is 4. And 78 over 100, which is exactly what that says. So you got two ways to pick whichever one you like the most. Here again, I'm going to do it both ways. 1.45 plus 2 point, and again, this is 0.15, 3 over 20. Okay, again, the 20s you can work with. So 3 over 20 becomes 2.15, and then it's really simple now. 145 plus 2.15, and 0, 6, 3.6. So this would be 3.6. Let me do it as a fraction. As a fraction, it'd be 1 and then 145 over 100, right? If you wrote it like that, plus 2 and 3/20, which we can change to 145 over 100, plus 2, and the 20 is going to become 100, right? So how did the 20 become 100 times 5? So on top is times 5, 3 times 5 is 15. Now we can add. There is no whole number here, right? So that whole number that's not there, plus 2 is just 2. 145 plus 15 is 160 over 100. Again, we run to that problem where this is a mixed number with an improper fraction. So this 2 is going to stay, but the 100 goes into 160 one time. 60 left over 100. We can't have two whole numbers, so I'm going to add this 2 is 1. So we're going to get 3 and 60 over 100, which is hopefully what I got when I did the decimal. And I think this is it for this particular sheet. And I'll get to the other a little bit later.